And I guess we should be live right now, everybody. Thank you very much for joining today's webinar. We're super excited to have you here again on another Day live event. As many of you have joined already, you may guess my name, Milana. I'm the Community Program Manager of WeAreDevelopers. We have one group of 15 people that always join the webinars, and I guess they are one of our biggest supporters. So thank you very much for being here every time. And make sure you share this event with your friends, and so they can also benefit from the knowledge that Milan will be sharing with us today. A couple of house rules for everybody who is new to this. Please introduce yourself in the public chat in the right corner of your screen. There is a public chat where you can say hi, you can say where you're from, you can say why you're here today. Tell us what do you love to do and how do you deal with actually this quarantine time right now. Another thing that is really important for us and for Milan is to ask questions. If you have questions next to the public chat, there is a Q&A mode. You can write questions there so he can answer them either throughout the presentation or at the end as they come and go. And yeah, last but not least, you'll see one message on the top of the chat, which actually is an ask for you to be kind, to be inclusive with everybody who is here today, because our online events comply with our code of conduct as our physical events as well. So yeah, we're not going to tolerate any inappropriate comments or any disturbing comments. So we'll be monitoring for them. And yeah, what should I tell you? Which I haven't mentioned yet is what we do. We're developers. We're developers. We do one of the biggest events in Europe for developers in Vienna and in Berlin. This year we had to cancel our event in Berlin, but that's why we have this every week webinars to entertain you. And except for this, we also have a job platform where you can search for a job, look for a job if you're a developer, or if you need developers in your team, you can actually post a free ad. So go ahead and check WeAreDevelopers.com at the end and see what opportunities you can provide or what also you can actually get from the platform. And I think the time has finally come right now to start with our workshop. Milan is one of our most committed speakers, been on a couple of events of WeAreDevelopers, and we really love having him on stage or online in that case as well. He's a network certified trainer, and I think he's one of the best people who can actually teach you about Swift. So without further ado, I'm going to mute myself and turn off my camera. And Milan, everything's in your hand. You'll be sharing the screen, showing you some code. And yeah, be active in the comments, be active in the questions section, and let's have a great time.
Okay. Thank you really very much. We go on. I will share my screen right now. Just a few seconds, please. Okay, and I hope you see my keynote presentation right now. I believe it is so. Okay, so we will talk about preventing memory issues in iOS development with Swift programming language. I will mention a couple of important information about memory related to other operating systems, and to other languages, not only to Swift, but of course the main focus will be in Swift. So what is this story about? It is very important that we understand what exactly happens in memory. It is important that we know how to make experiments, how to know what type of problems can we expect, how to solve, and how to prevent these issues. I will show you a couple tools for developers, and I will tell, as I mentioned already, how is about other languages. I believe it is very useful to compare Swift to other languages and to compare. It is important from my perspective to understand the whole story the whole story behind. So, what exactly happens in memory when we produce objects? We generally talk about two kinds of types. We talk about value types and the reference types. As I said, it is not only about Swift; it is about other object-oriented programming languages too. Value types. Just to mention what happened, how it was before. Objective C as uh, Apple's language was based on the C and on Smalltalk. Smalltalk is one very old programming language, object oriented, and Objective C actually has been made from C and Smalltalk. And all objects in Objective C has been accessed by pointers. By So everything was, let's say, by reference. Uh, Swift works with three kinds of types generally: classes on one hand, structures and enumerations on the other hand. Classes are reference types, and enums and structures are value types. So what is this all about? Let's go a little bit in Xcode. Here I have prepared one project, one empty project, which is named Memory WeAreDevelopers. And I have some code snippets which I will use during this presentation. So let's see one class, simple class, and one simple structure. So it is almost same, only keyword is different. Here is the keyword class, here is keyword struct. But what actually is the difference? Difference happens when we make an object based on the class or structure. Let me see how does it look like. In this function, we will make one instance of structure, and then we are going to copy it. Then we will use, and then change information, and then use again. So let us invoke this function, and let's see what is going on. Now I will start my project, and you will see the screen of simulator. Down there is our console, okay, our debug window. When we printed values for the first time, both are same. After we changed content of one structure and content of another, the second structure, they are different now. What actually happened? I believe it will be fully clear after this slide. So this is number one. Here is the object, and here is the here is the var. Okay, it is variable. And what happens after copying? In the case of structure, we will get another copy of object, and we of course have another fully independent variable. So we always consider the reference, we consider the identifier with reference to the object. It is wrong to say that the object has name. No, it is not like that. It is always about having an identifier, about having an object, and the reference between, the link between, let's say. So when we are copying the full object. So in the case of classes, it is different situation. We have class, we have the same model, but after copying, we have fully different scenario. So we have another identifier which is linked, which is reference to the same object, and it changes the game fully. Let's see what happens here in Xcode. Okay, so let's start it, and let's see the difference, because both variables are looking at the same object. Okay, changing one object like here, okay, changes using one reference to change the object, it it will change only one existing object. So this is the scenario we have. So it is very important to have this in mind, because the really big number of errors, of bugs, is based on the forgetting of this fact. So structures you work on one way, classes on the another way. But okay, why is this so important? Uh, I will make just one comparison, which is, as I mentioned, related to practically all object-oriented languages. So structures are structure objects are allocated on stacks, and class objects are allocated in heap. Stack and heap are two very important topics. So stacks and heaps are parts of memory of device, and both stack and heap resides in RAM, in memory, when app is running. But stack is using static memory allocation, and heap is for dynamic allocation. Stack is fast, easy accessible, easy to clear, but it is usually small. On the other hand, heap can use all available memory, but heap sometimes is slower, and there are some uh, other other things heap is doing lower performance than stack. But as I mentioned, both structs and classes, both stack and heap, are very useful, and it is the matter of context what we are going to use, stack or heap. In the case of multi-threading, each thread has its own stack, so the functions are isolated between threads, and in case of multi-threading, using of structures makes things more clear and makes things more easy to understand. Heap is shared in case of multi-threading on the level of the app. So of course, every single app has its own heap, but one app has one heap, and all threads can access the same heap. A little bit later, I will continue these considerations. I think that every developer should understand these topics and should understand differences between stack and heap. Now we are uh, now we are approaching the most important topic of this talk. It is automatic reference counting. Actually, this is the way how is Swift managing the memory, and I believe that it will be fully clear after this talk. Let's go a little bit back to Xcode to show some important things, and actually we will try to answer to the question what to do when we do not object anymore, when object is not needed anymore. Let's go to Xcode. So I will put here one actually not one, actually we'll put two classes. One class is person. It has a name, and it has a link reference to apartment. Another class is apartment, and it has tenant, which is property, which will tell uh, what who is the tenant of this apartment from the point of view of person, which apartment has been rented or used by person. It is story about modeling in computer programming. So we are defining classes in order to make a model of data. So this is, I believe, fully understandable um, example. And I will tell you that these all the examples I'm showing here are from Swift.org site. Actually from the book or content which is about Swift developers guide. Okay, so I didn't want to search for or to think about some additional examples. Everything I'm demonstrating here you can see on the Swift.org. So let's see what actually happens if we um, invoke functions. Okay, so I believe I have it here in. No, it's not that. Just a second. Okay, yes, it is. So I have two new functions, and okay, so no, this one is not needed yet, but this function number 5 is what I exactly needed. I will put this to comments and invoke new function. Okay, so what we have here? We have two identifiers for person and for apartment. We are going to make two instances, okay, and we are going to link those two objects one to each other. Then we are going to use, and then we will release these objects. Let us show how does it looks like graphically. So, okay, uh, just what happens here actually. It is very simple with structures and elements. They are on stacks, and when instance of structure or element is not needed anymore, the stack just put put out all the content. As I said, it is very simple because the uh, processors have the way how to work with stacks. This is the reason why is this so easy. But class instances are in the heap, and it is necessary to, so to speak, count the number of references to one specific object. How automatic reference counting works? It actually counts the number of current references is if you can remember my slide of a couple I showed a couple minutes ago. You saw that there are two references to the same object. It can be many references to the same object, and IRC actually checks the number, and if the number goes to 0, that means that the object is not needed anymore, and in this case, this object will be automatically removed from the heap. Graphically, so in the top right corner is the code you see before in Xcode. So John is a person, and there is unit for A, and now we are going to make objects. It's quite straightforward. Okay, this is object, this is the model I mentioned, and the apartment. And now those two objects are going to be linked, referenced to each other. And Okay, apartment is looking to instance of apartment. Tenant is going to look at the instance of person, and I believe it's quite clear. But after using, it is quite okay. Printing is simple, uh, simple example of using. But if we do not need this reference anymore, uh, it is reasonable to expect that the memory is going to be cleared. But this, in this situation, uh, we can actually have some confusion. You see, after setting John and unit 48 to nil, we have two objects that are looking to each other, and both objects have one reference looking to it. So we have so-called the reference cycle, or usually it's also retain cycle, reference cycle or retain cycle. Both words are in use. So, and this is actually the way how we are going to make IRC confused. So in this case, this will this will perform so-called memory leak. And now I would like to show you a demonstration how what happens actually in the in the memory of machine. Okay, it is so so if I start this, okay, you're going to see that actually nothing happens. But it is nothing because it is only one retain cycle. But let's make things a little bit more complex. Okay. Let's make 10,000 of it. Okay, for sorry, oops. Okay, now you're not going to see the issue at all because memories of these devices are very big, but you have really a lot of objects. So there is a way how we can uh, watch over this problem, how we can manage this, and how can we know that we have uh, cycles like this. So I will now show you the memory graph, which is the tool in Xcode. I'm going to start this right now, and I put breakpoint here, and you will see that the execution of the program has been stopped here after creating 10,000 retain cycles. The tool is memory graph, and you can start it here, debug memory graph. I will show you how does it look like. And here you see that you have 10,000 of apartments. And so this is the issue, and 10,000 of person. And this is not going to be cleared out of memory until the app ends. So this could be issue. Let's take a look to what happen if we have 100,000 of these. Okay, and before execution, I will put another breakpoint to show you the status of the memory before and the status of the memory after. So before execution, please take a look. This is the amount of memory used right now. Let's take a look to memory graph. Okay, memory graph. Okay, it's not it's not big issue because some reason you don't want to change, but never mind. Okay, let's as I said, let's take a look here to. Oh, yes, this is the reason why I know. Sorry. Yeah, you see, now we still do not have instances of apartment and person. But if I continue with the execution, okay, please take a look to the amount of memory. It's much more, and the number of retained cycles is much bigger. And so if we it is really reasonable to expect to have hundred thousands of objects in standard apps. It is not a big issue to have such a big number, especially if the objects are taking more memory. And it is important to think about this everything. So I will show you one more way how you can see issues and how you can analyze your program. It is the so-called profiler. It will take a while to start profiler because it is preparing, Xcode is preparing the code for execution, program for execution. A few more seconds, please. Okay, this is profiler, so-called instruments. This is the way how developers in Xcode can profile a lot of things. Uh, it's for us it is leaks what is important right now, and this is exactly what I'm going to choose. So I can start execution of my program by starting this recording button. And let's okay, let's see what is going on. So this tool is checking leaks. It's checking if there are issues. Yes, here is the issue. You see why is there the issue. Let me stop execution and let me check what is the issue. So the issue is that instances of apartments and person are locked to, to each other. I suggest to every developer to use frequently this tool to check if there are these types of memory leaks in the execution of the app. So the important question is, how do we solve this issue? There is one uh, very very specific way. So here in the apartment, we can use the keyword weak to say that this reference is not a strong reference, default reference of strong references. This is a weak reference. And what does it mean? Let's go back to our keynote and let's have a look. So if we have weak, as we we use the keyword weak, we have a weak reference. So after execution, okay, ARC, automatic reference counter, counts how many strong references are looking to one object. At this very moment, there is only one strong reference. It was only one. Now it's zero strong references because tenant is not a strong references, and this is the reason why automatic reference counter will say that this object should be removed because there are no references looking to apartment. It is ready to free this object too, and everything is okay. uh, John and unit are references are variables, and after ending of execution of this function, uh, they will they will not exist anymore. So let us check what happened now, and now with our memory. And so let us put a breakpoint here. Okay, let's start. Okay, so okay, this is here. All right. Okay, it's been executed. So how about memory graph? So you don't see issues. And of course, we can start the same in Profiler, which is here already. I will restart my app. And so there are no leaks. It is quite okay. So uh, all we need to do is to think what references uh, should be weak, and I will say a little bit later how can we know uh, what we can say to be weak. Okay, and there is one example more, a little bit different, and as I mentioned, it is about making models. Model of person at apartment means that there can be a person which is not using any apartment, and apartment can exist without being used by a person. So those two objects can exist independently, and but they're different models, like this one with customer and credit card. Of course, customer can exist without having credit card, but credit card has customer. The customer is being required. Of course, Swift has optionals, and it can solve one part of the issue. But in the case of credit card, uh, this is the way how this cycle, how retain cycle starts, and the way how do we solve is to use uh, another keyword which is unowned. Let us take a look to graphical representation. Okay, and so this is the code, and there is John, and when instantiating of customer, okay, uh, in this line, John.card is credit card. Okay, here is going to here is going to be instantiated one credit card, and this is the standard cycle of both. This is the standard reference cycle of two strong references. Okay, it is quite common thing, but The solution in this case is to use unowned references, and of course it is quite clear what happens, right? But unowned reference. Okay. Now, automatic reference counter counts number of references, number of strong references, of course, and there is no one strong references located to customer, and this is the reason why this object will be removed from the memory. So we had two examples. The third example is with closures. Closures are one very powerful concept in Swift and many other languages. So closures are objects too. Closures are functions without name, but they are reference objects too. So whenever we have a reference object that will be passed by reference, we always can have an issue with retain cycle. So as I said, closures are object too, and so we have object with closure as HTML. So the closure is referencing name and text from this HTML element. Okay, and this is the way how we get retain cycle. In the case of closures, the way of solving is using so-called captured lists. So here we are. Okay. So as I mentioned, closures are objects too, passed by reference. Solutions are captured lists. We use capture lists to explicitly control how values are captured in the closure. How values are captured in closure. We would place the capture list before closure parameters and return type, and it looks like this. By using this capture list, we say that this self is unowned or is weak. Unowned self or weak delegate, it is syntactic sugar. So in the case of real code, it would look like this. Okay, and so this is the closure, and by putting this piece of code, we will solve this without issues. Okay, I believe it's quite straightforward now. So let's just take a look over a few considerations when we use weak, when we use unowned. So when objects are independent, like in case of person and department, we use weak. So weak references are always often optional. This is the question mark you could see. So weaks are using when we can have a reference to the object or have a nil. In the cases when objects in relation are required, like in case of credit card, we should use unowned. Weak and unowned and strong are so-called modifiers, storage modifiers. Strong, we can use keyword strong, but it is not necessary. All by default, all references are strong. So unowned cannot be optional. It expects to have value. So in the case of closures, we define capture list and we use unowned self or weak self depending on the same criteria. Uh, can it be independent or it has to have value? Let's say a few more words about general concepts of so-called garbage collector and compare it to IRC. Automatic reference counter is coming from the LLVM world, low-level virtual machine, what is actually the base for Swift. This is the project Chris Lautner is leading to. But many other programming languages, object-oriented, have garbage, so-called garbage collector. Uh, Swift and Apple do not use garbage collectors. They use automatic reference counting. So let's uh, let's uh, let's say that garbage collector is a piece of software. So it is actually a piece of software which is running in the background at the same time when your app is running. But it is not part of your code. It is, so to speak, in background. Uh, Garbage collector starts on a time basis or when free memory is too low. Garbage collector uses algorithms to try to understand what objects are not needed anymore. It is a much smarter tool than ARC. It works automatically. So it is the tool, but it works automatically. Garbage collector do not require any actions from developer actually, but uh, automatic reference counter requires, as we saw. So this garbage collector recognizes retain cycles as well, and but actually it requires a lot of more of memory for fast execution. I suggest to everyone to try to read some papers about this, but if we want fast working garbage collector, it requires up to 5 times more memory than basic app. So it is generally trading. It is trading for performance. Uh, Apple used Apple made decision to use automatic reference counters. Some other vendors use different approaches, garbage collectors, and different algorithms for garbage collectors. But this is not a football game. This is not about being fun of GC or ARC. It is about performances, of course. Okay. ARC is actually not a software. It is not a running solution. It is a technique, or so to speak, so to say, approach. And uh, Apple, yes, just to mention that Apple had a garbage collector for macOS in versions 10.5 until Mountain Lion, but now it is not the case. On the other hand, iOS never relied on garbage collector, but automatic reference counting requires attention of developer, and sometimes it is difficult, especially for a non-experienced developer. For non-experienced developer, it is of course the easiest way just to create objects whenever needed and without thinking. But automatic reference counting generally gives better performances. In many uh, scenarios, it is not too important, Uh, Sometimes it is not very important to have a high performance app, but when it comes to user interface, to user experience, personally I believe it is really important that app work fast. I'm sure there are people sharing my opinion too. So Objective-C, just to mention, can use automatic reference counting too, but Objective-C can be used in a way that developers think about everything, about free memory and so on. And so in the case of Objective-C, we have a manual reference counting too. Uh, so uh, in the case of automatic reference counting, you simply cannot forget about memory management. You need to think about this, but the value of this is very high. So let's just compare structures and classes. Both structures and classes are useful, but it depends on the context of use, what you are going to use, of course. Sometimes it's better to use structures, sometimes it's better to use classes. If you use structures, you do not think about automatic reference counting, about references, and so on. On the other hand, there's plenty of things you cannot do with structures, but you can with classes. I will just give for the end give a few advices for developers, because the name of this presentation is how to prevent memory issues. So my advices would be so the producing of quality code, it is a matter of habit. You will be good developer if you have a habit to be a good developer. Taking care about memory and managing memory is one great habit, of course. Not only one, but I believe required one. Uh, you should use structures instead of classes whenever possible. But and Apple is forcing passing by value. But in one sentence, just to mention that Swift is has been coming after Objective-C, and both Objective-C and Swift use the same libraries for graphical representation. Apple is forcing using of structures because it's more clear, it's easier, sometimes it's faster, usually it's faster, and generally, but at this moment, classes are here to stay too, as structures as well. So another advice: keep data separate of presentation. Have in mind to use architectural patterns like MVC or model view model and other as strictly, or at least to have it in your minds. Keep data separate from views. Keep data separate from presentation. Use let instead of var, so use constants instead of variables whenever possible, because it will produce better performances. It is about low level virtual machine. It is about the very strong optimization performed by compiler, and compiler will do this job easier if you as developer are using let instead of var. Avoid generally global variables whenever possible. When closures are very good, very powerful, but please, whenever you write a closure, check for capture list. I am aware it can be annoying sometimes, but it is necessary and it has great value, as I already mentioned. So when you use delegation pattern, when you use delegates like data source with table view or similar, check, do you ask question to yourself, do I need to use weak or maybe I'm old? So, okay. I show you memory graph, memory gauge and instruments, and these tools should be used when you prepare and you are in process of preparing your app for App Store. My suggestion is use instruments, memory graph, whatever needed to identify if there are memory leaks. So general suggestion is to use protocols instead of classes because it generally helps compiler to do better job, as I already mentioned. So use protocol instead of inheritance, which is related to classes, of course. So as I mentioned, automatic reference counting is feature or low level virtual machine infrastructure. And there are some other languages that use this too. As I mentioned, Objective-C, but I will mention Rust, which is not Apple's language at all, which is low-level virtual machine-based language too, and it uses automatic reference counting. Okay, so just quick summary. Many, 10 minutes more. Many languages use the garbage collector. Java and .NET, they use managed code, but they both use garbage collectors. So automatic reference counting enables great performances, but it requires attention of developer. And all is this because Swift is compiler, and it produces compiled code which is generally faster. Everything we spoke about in last hour is because of performances. Okay, now I will go back. I will end my screen sharing. Just a second, I hear. Okay. So here I am, and now I would like to go to Q&A mode. Okay, any questions? Does it get worse with Swift UI? Well, no, it's not worse. I I don't think this is bad, but it is not worse after all. No, it is again about objects. It is again about closure. It is more about closures when it comes to Swift UI, but it's. I don't think. I think it is about habit. After a while, I'm sure that every developer can solve it really quick. Okay. Of course. Any other question? No, it is not. No, it is not necessary to use on both sides, because we have. It is enough to have one object which reference count will go to 0. Okay, automatically it will be removed from the memory, and the another one stay without reference. So it is quite okay, but it is sufficient to use weak on one side only. Oh. Okay.
Okay, I am back just to support Milan in the moderation to see if actually there are any other questions left. Cheers, nice glass.
Okay. These two guys work based on the automatic reference counting. Trust me.
Cool. Yeah, it seems like actually everything was clear that you said, that you talked about, and there are not so many questions this time.